thank you everyone for joining my presentation. Let's see if the slides pop up. There you go. Cool. All right. Yeah, thank you for everyone for being here. It's actually a great venue. I'm super happy to be here. My name was introduced as Alberto from Moonbeam. I do developer relations, and today I'm going to talk to you about Moonbeam in an interoperable future, right? And so in the structure of the talk, we're going to start with Polkadot. You know, this is ParisDOT. People should be familiar with Polkadot, but why not? It will only take a minute, right? The next part that we're going to talk about is about Moonbeam, very briefly. What is it? What makes Moonbeam special? And last but not least, we're going to focus a bunch of the presentation into interoperability. What Moonbeam offers and what makes interoperability important in the future of blockchain. So I really like this meme at the right-hand side, because it explains in a very simple image what Moonbeam does, right? One of the main ideas of Moonbeam is to bring Ethereum developers closer to Polkadot. But what is Polkadot, right? And I only will use 1 minute of the presentation to explain Polkadot, but it's important to set the precedent of interoperability. And so Polkadot, the main idea is that there are many best blockchains. There's no one blockchain to rule them all, right? It's not like the Lord of the Rings ring. And so Polkadot provides two main things, right? It provides, connects different blockchains in an ecosystem and secures them. So any blockchain that is part of Polkadot has these two benefits, okay? And the blockchains that connect to Polkadot are called parachains, and they provide they're specialized blockchains that provide specific functionalities to the ecosystem. So I don't know if you guys know, but in Polkadot, you cannot really develop. You cannot, as an app developer, you cannot really build on top of Polkadot, right? You can only stake and do governance. And so that is why Polkadot has these specialized parachains or blockchains, because each parachain will provide a specific function to the ecosystem. And last but not least, XCM is basically the technology that allows all these participants in the ecosystem to basically interact with each other. So I'd really like to say two things about Polkadot, is that in Polkadot, the parachains are nothing without Polkadot, or the relay chain, that's how it's called. But the relay chain is nothing with the parachains, right? Because if one doesn't have the other, there's a missing piece in the ecosystem. But the other important thing about Polkadot is that it has to live to the promise of interoperability, right? If Polkadot is not an interoperable ecosystem, Polkadot doesn't really offer anything special out of just shared security, right? And that is why we're going to focus quite a bit of the presentation today in interoperability. So the question is now, what is Moonbeam? It's going to be also very brief, but as you might know already, Moonbeam is an Ethereum-compatible smart contract platform in Polkadot, right? So our main thing that we offer the ecosystem is to be a smart contract platform, where we're fully focused on providing the most Ethereum-compatible parachain in the ecosystem. And so, as with any basically EVM-compatible parachain, we part from the bottom layer, which is the EVM, and we have like added layers of functionalities on top of the regular EVM implementation. The first one is that we're built with Substrate, which is this framework to build blockchains, not necessarily for Polkadot, but it's the easiest way to connect to Polkadot. And if we connect to Polkadot, we have interoperability as a given, right? The next thing is that we have a fully compatible Web3 RPC. If you're a developer, you might know what this means, but if you're a user, you actually have used this feature without not even knowing. If you've ever used Moonbeam in the dApp, for example, you interact with it through MetaMask, right? And MetaMask communicates through this Web3 RPC. So that's why in Moonbeam, you can do all the interactions that you do with MetaMask. The next feature is unified accounts, and that is only specific to Moonbeam, I think. And it's that all the interactions that you do in Moonbeam is with an Ethereum-style account. You will never use Polkadot.js extension for now. So let's see in the future it supports Ethereum-style accounts. But you never use a Polkadot.js extension. You will always use Ethereum-based wallets such as MetaMask, Ledger, Trezor, Math Wallet, and then other wallets in the ecosystem. And last but not least, Moonbeam is really focused on providing an Ethereum dev-like environment, like I've mentioned before, with expanded features. And I'm going to touch base on these expanded features in a bit. And we were trying to aim to be an interoperability hub, not only within the Polkadot ecosystem, but to communicate Polkadot and Kusama to other chains like Cosmos, Avalanche, Polygon, whatever. So I really like this phrase about Moonbeam Composability because we're trying to bootstrap now an interoperable ecosystem. It's not only a regular ecosystem like Ethereum has, right? You have lending protocols, you have DEXs, you have stable coins, you have stable swaps or stable DEXs, derivatives. This all has, Ethereum has this. And for me personally, it's one of the things that I love most about Ethereum. It's just that all these projects can actually interact with each other atomically in a single transaction by just coding some stuff without needing requirements or like authorizations. It's all decentralized and it's all in the blockchain. So one of the things that we actually noticed is that in order to bring sort of like Moonbeam into the same stage, the first part was that we needed to have a tooling, right? So developers wanted tools that they're already familiar with, and because we want to be the most Ethereum-compatible parachain, we needed to bring these tools to Moonbeam. So for example, that's why in Moonbeam or Moonriver, you find the graph, Covalent, you have Chainlink, you have MetaMask, Trezor, Ledger, you have Etherscan, some Ethereum development environments like Truffle, Hardhat, Ether.js. And then you also have in the bottom layer here, what I like to call bridges, right? I mean, for Polkadot, bridges is not a really great word because it's native interoperability, but you have these sort of like interoperability protocols. I think that's a better name. So Moonbeam can actually benefit from Polkadot to communicate within the ecosystem. So with parachains like Fala, Kala, or Karua, Akala, depending on Kusama or Polkadot. But we also leverage, and we're actually quite focused right now on leveraging message passing protocols such as Axelar or Nomad to actually communicate with blockchains outside of the ecosystem. And so that's why I like to say that in Moonbeam you will find interoperable composability that will leverage both XCM and then GMP, which is general message passing protocols. All right, I mentioned EVM with expanded features, and I'm bringing this up because later on when we talk about interoperability, we're going to talk about how we make interoperability sort of Ethereum friendly, okay? So we like to say that we have an EVM with expanded features because you guys, without not even knowing, if you're users of the Moonbeam platform, you're doing interactions that are actually part of Substrate. So they're not part of like a smart contract on Ethereum or in the EVM. They're actually baked in functions in Substrate that in regular blockchains, you will interact with it through Polkadot.js apps or the extension. So for example, the staking precompile is what allowed you as a user of Moonbeam or Moonriver to stake in the Moonbeam dApp using MetaMask, Ledger, and all these wallets that I've mentioned probably too many times by now. We also have a democracy precompile, which if you ever used Polkassembly before, Polkassembly has a very unique feature for Moonbeam-based networks in which you can actually vote in the network in Polkassembly using MetaMask, right? So it's not only a forum-based platform, you can actually vote in it using MetaMask and these other wallets that I won't name again. We also have an ERC20 precompile, and the idea of this is that Glimmer, so the token of Moonbeam, for example, can exist as a native token, but can also exist as an ERC20. So you can see here that I'm going to add Glimmer as an ERC20, and I can actually send it as it was an ERC20 to any other participant in the network. And this is really cool because if you're a DEX, you don't need to have to wrap it, unwrap it, and so you're actually saving gas in the process. And last but not least, we have, if any of you guys participated in the Moonbeam or Moonriver crowd loans, oh, sorry, no, the batch precompile. I went a little bit ahead of myself. This is one of the newest precompiles, and it's one that I'm really excited about because it allows you to batch Ethereum calls, right? So you guys probably, if you interacted with a DEX before, it's a two-step action. You have to approve first, and then you have to confirm the swap, right? With a batch precompile, the developers can actually batch these two Ethereum transactions or EVM transactions into one. And you can actually do this for 10, 20, as much as the gas allows you to do it. And last but not least, like I mentioned before, if you've ever participated in the Moonriver or Moonbeam crowd loans, you go ahead into the Moonbeam dApp, and then you claim your rewards using this little nice button that you see here. And it starts, once again, an Ethereum-like experience with MetaMask and all these other wallets. And that's thanks to the crowd loan precompile. And we have others that I'm not going to mention. But if you have any questions about any of these, if you're a developer and you're interested, you can go by the booth and ask specific questions about them. So we reach interoperability. I promised that we were going to spend some time in this. So interoperability in Polkadot, you have to talk about XCM. So XCM, there are many ways to think about XCM because you can think of it as a developer, which is going to be a little bit harder. You can think it as a regular user. And so I prefer to take the second approach. So XCM, it's a message with a given format and a set of instructions, right? So imagine in a regular email that you're sending to your boss or whatever, you're like, hi, Alice, how you doing, right? You have a specific format, and then you can say, hey, Alice, can you do this for me? Can you go back and grab this? And then you give a series of instructions, and then you say goodbye, right? I mean, if you're a developer, don't kill me, but it's like a way that I like to say that XCM is. It's a message format with a series of instructions, basically. And then you have the XE virtual machine, which is, once again, it's not technically true, but it's like the Ethereum virtual machine, the EVM, but specific for XCM instructions, right? So if the instruction is go over there and turn off the lights, that computer will understand that instruction and execute it, okay? And then you have the communication channels. And this is where I'm going to show a picture, and you're going to hopefully understand the picture later on, because that's why I want to explain the communication channels. So this is what connects the chain A with chain B. And it's unidirectional, right? So if we connect, for example, with Fala, that I'm using as an example because it was before me, Moonbeam has to connect to Fala, and then Fala has to connect to Moonbeam. That's how it works. That's why you always see two arrows here. And these channels allow message passing in that given direction. Any parachain that connected already to Polkadot and Kusama has already a channel with the Polkadot and Kusama. It doesn't have to open a new channel. And then last but not least, we have sort of like the type of channels that exist, right? So if Moonbeam wants to connect with Polkadot, it's actually called UMP. It's like the transport, the way that message is transported. If Polkadot wants to communicate with Moonbeam, it does DMP. And then between Parachain is XCMP, or actually right now is HRMP. It's just fancy names, basically. All right, so Polkadot and XCM instructions, and I've mentioned this before. So these are three instructions that I grab as an example. You know, they're not my favorite or anything, but you can find in this link all the list of instructions that XCM provides to developers. The important thing to understand is that a combination of these instructions is what's going to have a specific action in the XCM message, right? So if I tell another parachain, hey, I want you to walk 5 steps, go into the light switch, turn it off, and then come back, right? So these 3 instructions that I'm saying, probably 4, it's the parachain is going to execute them, understand them, and then do the action, okay? So it's a combination of XCM instructions what actually provides sort of like a specific action in the target parachain. So these 3, for example, are one that are actually used to open a channel with another parachain. If I want to open a channel with a Kala, for example, I would send an XCM message with these 3 instructions, and in the transact, I would actually tell Polkadot, hey, Polkadot, I want to open a channel with a Kala. All right, but that's more or less what it works, how it works. And another important sort of topic that I want to bring is weight. Weight is a very, once again, sort of like definition, but I'll try to make it simple, right? So the idea of weight is that when you execute an action, so let's say I want to transfer tokens to Alice, that is going to take some time to execute in the block, right? So there's an action that needs to be executed. And so that action is measured in seconds. And basically, if it took 0.0002 seconds, that it's like 20 billion whatever weights, okay? So that is a conversion. And so basically, for XCM, and this is not XCM specific, like I said, but for XCM, this also implies that there's some weights attached to it. And so the idea is that every single instruction has an amount of weight. So think weight, once again, as time that it gets to execute that action or that instruction. And then there's associated cost with that, right? So when we send an XCM to Polkadot, we have to understand that these 3 transactions, I didn't include the transact one because of space, but are going to cost me around 0.033 dots, right? And so the message has to understand that it has 0.033 dots in order to be executed, okay? One thing that you might notice here, and you might ask, is like, why is it so expensive, 1 billion weight in Polkadot, and why it's so cheap on Kusama? And that is because on Polkadot, they have not yet measured how much each instruction actually takes. What they do is they grab a computer that they have somewhere, or like a standard hardware, and they say, okay, in this computer, this instruction withdraw asset took this much time to execute. But in Polkadot, they just say, okay, we don't know yet, so I'm just going to put a very high number just to make sure that it's okay. That's how it works, okay? And then in Moonbeam, we've not yet benchmarked once again, and so that's why we have a little bit of a lower number, but it's a fixed number by instruction. Because you can see, for example, in Kusama that withdraw asset takes this much, and by execution takes like a fraction of that, but on Polkadot, it costs the same. And it's not really fair, right? So this is the picture that I wanted to show you with the channels. So you can see here that you have Kusama, and this is on 14th of July, because this is changing constantly, so it's really hard. You can see all these different dots that you see here are different parachains. Some of them are here. This is Kusama, and this is Polkadot. And all of these parachains are actually interconnected natively, trustlessly, in a decentralized way. And this picture actually, it's really cool if you think about it. Because it's not the same as using, whatever project to bridge Ethereum to Moonbeam or to Avax or whatever, right? This is natively given by Polkadot and Kusama. And this website, by the way, to give credit what credit is due, it was done by one of the team members of Akala. On the right-hand side, because XCM was actually much earlier, like it was released, not long ago. The XCM channels are not that much or that many, as you can see here on the left-hand side. But you can see that this is actually a number from Polkaholic, which is an XCM explorer, and I think it's correct. But you can see that the total, basically, volume that has been moved in Kusama in the last 7 days, it's roughly 100 million. And then in Polkadot, it's for 450 million, which is pretty crazy. All right, so now I want to talk about the different use cases that XCM brings, right? And the first one that everybody knows, because it's the most common one, is transferring tokens, right? So on Moonbeam, you can bring DOT as XC DOT. You can bring AUSD from Akala as XC AUSD. So once again, at a very high level, this is very simplified. How does it work? In simple terms, basically what you do is that you through XCM, don't do this like balance transfer, oh, that's it, right? Through XCM, what you do is that you actually instruct Polkadot with this given XCM instruction, and this XCM instruction will transfer tokens from the account that you want to transfer it from to a special account that is owned by Moonbeam or by the Parachain. So there's no like single person controlling that account. And so this XCM instruction will actually follow up with, okay, after you execute this, you're going to send an XCM to the destination chain with these 4 instructions that you see down here. All right, and these 4 instructions, as a summary, is going to basically, because it comes from this event, it's going to say, okay, I know that this person transferred tokens to this special account, so I can basically mint an XC dot, which is a representation of Polkadot, and give it to whatever destination that person decided to put, okay? Once again, very high level. I mean, it's not, I don't want to go into too much detail, but this is how, at a very high level, remote transfer works. The second one, which is I'm more excited to tell you about, is Lido. So basically, this is remote execution. And I'm going to tell you a little bit more later. But the idea is that you can trustlessly execute in a remote chain, for example, DOT or KSM. And for example, the way that Lido does it is that you can stake on Polkadot and Kusama by initiating a transfer on Moonbeam. And this is really cool if you think about it, because this is native interoperability that allows you to stake DOT, but you can sign it with MetaMask, for example, right? Which I think is pretty cool. And the user, if you have ever used Lido, the user has no idea what's happening on the background. They just sign a transaction with MetaMask, and then they just get some tokens, and then they're actually staking DOT, which is pretty cool. And last but not least, this is still not available, but this is what we're aiming for, is remote EVM calls. So the idea is that projects are interested into using the Moonbeam EVM. And so the idea is that they can actually, from other blockchains, they can call Moonbeam and call it smart contracts there and say, hey, I want you to execute this for me, right? So the same way that you can use Falas Cloud Computing, we want to enable the EVM calls into our chain through XCM, which would be also quite an achievement. And once again, this is trustlessly and remotely, right? This is completely given by the protocol because we're connected to Polkadot and Kusama. So now let's talk about XCM, Polkadot, and Moonbeam, more specific about Moonbeam. The first thing that we introduced was the XC20s. So the XC20s are basically a way that we made to have sort of like these interoperable assets like DOT. You can actually access them as an ERC20 on Moonbeam. What this means is that if you have DOT on Moonbeam, you can actually add it to MetaMask as an ERC20, or actually developers can use it in smart contracts natively. It's really, really simple to use XC DOT as an ERC20 on Moonbeam. And that's why, for example, you can do liquid staking with Lido for Polkadot. So this is a demo, that video of me adding, for example, Polkadot to MetaMask using the Moonbeam dApp. So you can see here that I added it, and I have the XC dot in MetaMask, and I could just send it here to anyone in the ecosystem, or I could do it some other stuff. The next thing is the X tokens. So this is another precompile, and these are precompiles, by the way. This is another precompile to actually allows you to send XC20 tokens, so XC dot, XCA USD, to any parachain in the ecosystem using the Ethereum Web3 RPC, right? So in theory, you could sign this transaction once again in MetaMask, and then that transaction will send DOT from Moonbeam to Polkadot, or AUSD from Moonbeam to Akala, and so on. And this is the one that I'm the most excited about, which is the Lido example. So how this works at a very high level is that a happy user here with this MetaMask ledger or whatever will actually interact with the Lido contracts to say, hey, I want to stake 5 XC dots, right? And so the Lido contracts will take those 5 XC dots and a little bit more, or actually a little bit less for fees, and then we'll actually call a special contract, in this case in Moonriver, that will interact with Kusama and tell Kusama, hey, I want you to grab 5 XC dots or 5 XC KSMs, convert them to a KSM, and stake them in this validator, all right? And that is all happening, once again, from a transaction that a user signed on Moonriver. The user don't really have to go to Polkadot.js apps, and it's staked through there. So this is a little bit of a summary of the XC20s that we have right now this is Moonriver. So you can see that we have roughly 75,000 XC KSMs. The one that is really cool to see is Remark, which we have 3.7 million XC Remarks on Moonriver. And then we have a bunch more that I did not have space to add here. On Moonbeam is a little bit less, because like I said, it's more recent. And so we have actually surpassed 1 million dots, which is pretty cool to see. Actually, recently, I think it was July the 8th. And then you can see that we have also AKAS, XCA USD, and so on. So last, to wrap it up, because I have 3 minutes left, let's talk about connected contracts. So the idea of connected contracts is a new concept that we're bringing to the table of making Moonbeam sort of like an interoperable hub for the entire blockchain ecosystem. So I don't know if you guys have seen that, for example, Sushi, for example, has many blockchains in many deployments on many blockchains. And that is called fragmented deployments. They have their smart contracts on AVAX, they have their smart contracts on Moonbeam, Moonriver, Ethereum. And that fragments liquidity, and that fragments users as well, right? So it's very difficult to maintain all these deployments across all these different networks and so on. And so you can see here that the idea of connected contracts is that you have sort of like a main hub of your smart contract logic on Moonbeam. And what you have in other chains are smaller versions of logic that are strong enough to handle whatever interaction the user is doing in that blockchain, but is bringing the bigger sort of load of the action and execution on Moonbeam, right? So for example, if a user, there's a protocol called Prime Protocol, you can actually deposit sort of like AVAX on Avalanche, and you can mint their stable token on Ethereum, right? And everything will go through Moonbeam as a central hub of interoperability. So the main benefit that this solves is first fragmentation, like I mentioned before. You can have all your assets or all your deployments centralized in one specific chain, and you have only smaller pieces of code around the blockchain ecosystem in general. The second thing is efficiency, and this is where Polkadot really comes into play, because I remember that I said that the sort of like Polkadot offers specialized blockchains, right? So if, let's say, a project on AVAX wants to use a SideHeist prediction market, they can come through Moonbeam, call the prediction market on SideHeist, which is a blockchain specific for that. So it's going to be the most efficient one, and then send it back the result to AVAX. And last but not least, and this Lido example is really good for this, it improves the UX by hiding the infrastructure complexity. All right, so the Lido example is great because if you've ever staken in Polkadot.js apps, they recently launched a new UI. Before, it was not easy for the user. It was really, not easy. They had to do a lot of hoops, a lot of processes, and so on. And in Lido, it's a one-click thing that you click, you say, I want to stake 5 dots, you click submit, and everything that is happening behind, which is a lot of things, the user has no clue about it. And so the idea, once again, is that Moonbeam can be sort of this like interoperability hub that can connect parachains in the Polkadot ecosystem outside to other blockchain participants through general message passing protocols, like I said before, but also this other sort of like protocols can see into Polkadot or Kusama through Moonbeam, and that's why we have all these like smart contracts precompiled to allow for these Ethereum sort of interactions with everything. And so, and the idea once again is that the user will just sign a very simple transaction even from their smartphone. So that's it for me. That's all I have for you today. I think I'm not sure if I have enough time for some questions or not, because the timer ran out, so I guess not. I'll be in the booth outside if you have any questions. These are like our social channels, a website, documentation site, Telegram, and today's presentation, you can find it in this QR code, or you can also visit bit.ly Moonbeam ParisDOT.Comm2022. So yeah, thank you for your attention.